How you doing? I'm Robert Davis. I come to y'all from Dallas, Texas. Originally, I was a Cisco engineer and learning how to automate networks, and I figured out I like development a lot better. So ended up moving to Austin. I'm a senior software architect here now. And here recently, I've been starting to dive into AI and specifically agentic development. So this is a little app called AIMUG. It's started out as a friend coming over to the house. He's a CTO of a startup, and as a lot of y'all are probably very buried in tasks. So I wanted to kind of turn him on to agentic development, see if I could kind of level up his game and help him out a little bit. So I asked him, I said, what do you want to, give me something simple. It's always simple at the beginning. He says, you know what, I want to be able to talk to my phone and get some behavior analysis from it. Like I want to be able to pour my heart out to my phone and have my phone kind of talk back to me, right? And give me some information. I said, you know what, let's take that a little further. Let's like actually do some actual analysis of what your journals are saying, things like that. So this is I'm going to warn you now, this isn't fully working at the moment. This is part of why I'm having this conversation. So basically just kind of show y'all what it does is it gives you ability to go in here and just kind of pour your heart out to the application here. You can tell it what your mood is, give it a title, tell it how you're feeling, tag it, relationship issues, things like that. I've already got some in here just to keep things simple. So yeah, once you give it the information, it basically is going to take that information and feed it down to a whole set of agents. So this just kind of give you a visual about what I'm about to talk about. So this is a case study on what not to do. So yeah, let's get into it. So AI-powered wellness through personalized journal analysis. As everybody knows, there's a lot of mental health issues in this world. All you got to do is turn on the news and see that. 1 in 5 adults experience mental health issues yearly. We all know about the stigmatism from having to admit that and what insurance companies may do to you if that information gets out. PI, HIPAA, we get into all those kind of concerns when you start talking about mental health, and then just the cost of therapy, right? There's so many that it's just a recurring thing. They want to keep bringing you back. Yeah, so it seemed like a really good thing to kind of tackle, right? So key features of software, anytime you're talking healthcare, encryption, security is going to be an issue. This one, instead of using one agent, we decided let's take it a little overboard here. I wanted to really test out Claude Code, his asynchronous coding abilities. I wanted to see if I could hit the 20x rate limiter and token generator at Anthropic, and yes, I was successful. So 6 agents, to make them nice and fun, I told it, go ahead and make them characters from movies. And I just let Claude, or actually to what Colin was saying, deep research. Most of my prompts are developed in a deep research like Gemini 2.5 or something like that. I will spend days literally talking to it, developing plans, and at the end, then I tell it, okay, this is how I want it done. I'm going to feed it to this LLM, so I need you to break it down, give it all the parameters, and have it break down the prompts. This one, I told it, just give me, YOLO, give me everything you got all at once. And so that's why months later, I'm still working on it. And that's why I'm here talking to y'all. So movie character personas, personalized mental health insights based on as you're journaling. It's going to take your previous journal entries. All of that stuff's going to go into a vector database called Weaviate, and allow the agents to be able to kind of analyze previous conversations along with new conversations, and also kind of allow them to analyze everything together since there's 6 of them. Progress tracking and end-to-end encryption. Again, when you're talking about health, potentially you're talking HIPAA, other things like that. It's kind of sensitive information. You want to make sure you get that covered. So the agents, this is what it came out with. Yoda, deep empathy and emotional validation. Doctor Strange, cognitive behavior, a CBT analysis. Morpheus, ACT therapy, acceptance and commitment. Tony Stark for habit formation and behavior coach, try and pick out any destructive tics that it sees inside your talking, things like using the overuse of the word just to, I feel like, or, just kind of destructive behavior habits. Picard, goal setting and achievement therapist, and the architect. The architect's kind of the heart and the matter of all of it. You're going to see here in the data flow just a minute. He kind of coordinates all the rest of them, and he's the main one that you kind of your entry and your exit point in and out of the agents in the RAG. So just on a high level, this is the agent flow. We're going to talk about it a little more here in a few minutes. Yeah, so Yoda's the empathetic listener. You see all the other ones down there. You got the orchestrator in the middle. User starts out by publishing a journal entry. That's going to go asynchronously over to the architect, to the master orchestrator, and he's basically going to feed that to the appropriate LLMs based on that behavior model. Eventually, they're going to return that response, and it's going to be done asynchronously as well. He will see those responses, and then he's going to take all of those responses and synthesize a response that goes then back to the user and gets displayed on the page as I showed earlier. High-level architecture. The user interface is React Native Expo framework. I like using the Expo framework when doing React Native because I am not a React Native engineer. Expo is something that the LLMs understand well, and when you can feed them a well-documented framework, things tend to go a lot better. So Expo is one of those because it's well-defined and it's got a well-defined set of libraries that work real well with each other. So if you kind of just guide it towards that and tell it to use Expo first libraries, you have a little bit more success, but you're going to end up with kind of a generic interface too. All that goes into a fast API service. We don't want, as y'all know, whenever you feed something to an LLM, it may take a few minutes for that, for it to process and chunk on that. These are not local agents, so yeah, it's going out to ChatGPT to talk to these guys. So we don't want to be sitting there, the user just sitting there waiting for all of this to happen. So agents being asynchronous in nature, then we want to use asynchronous ways of getting that information to them and pulling those back. So we send it to a fast API service who immediately unloads it into a RabbitMQ MQTT server. And that allows the agents to kind of chew on that stuff asynchronously while the user maybe gets it waiting, or he goes off and does something else, and then he comes back and he sees his results. LangChain and OpenAI obviously, for the group here. We are the LangChain group. He didn't start out doing that. I had to go back and make him refactor that, and we'll get to that in a few minutes. This has gone through about 4 different refactors. Weaviate for the vector DB, I would have rather used something else, but we went with it. And then Redis and Postgres for storing the encrypted data, and Redis for basically managing tokens, things like that. Just very quick, very fast, asynchronous store. So again, just kind of talk about the stack framework, React Native with Expo, React Context with hooks, React Navigation, and of course, testing, right? So just with React Native testing libraries. In the back end, we use Python with Fast API, LangChain with OpenAI ChatGPT-4, standard authentication, light authentication with JWT tokens, and then RESTful, and we're using some WebSockets for actually connecting back to the Fast API instead of just doing direct HTTP calls, something a little more asynchronous as well. And then infrastructure, all the backend services are containerized into Docker, much like what Collier was talking about. Message MQTT, RabbitMQ is for asynchronous message delivery, as I kind of laid out, and then Postgres, Redis, and Weaviate. Currently, everything's getting deployed just off my laptop using Docker Compose. If this ever went somewhere else, I would probably, I'm more of a Kubernetes guy. I know a lot of people have opinions about that, but I use it thoroughly through my day job. I help to manage probably half a dozen Kubernetes clusters. And so it's just something that we're really versed in, something I really like. If you're doing containers and you're willing to learn the platform, it's a great platform. It allows us to really scale very large. Again, a little bit deeper dive on the background here. Again, just showing the API layer, the service layer, and the agent layer. When you get into architecture, in this particular case, I let the LLM determine which architecture to use. This is what I would call more of a horizontal splice architecture, where we're setting up layers of functionality. Verdict's out still on how it did it, how well it did. There's other architectures that can be used. We played around with using Git trees and vertical slice architecture, if anybody's never heard of that, where you define a single feature and that feature is self-contained, kind of lends itself. If you're doing it as with the coding team, it's probably a nightmare, but when you're having an LLM do it, it's a new world. So we're taking old stuff that we didn't like before and seeing how it works with new stuff too. So that's another way you can think of it. The data flow here. So like I was talking about, the user writes the journal to his mobile app. That gets posted into the Fast API through WebSockets. And then that information gets stored encrypted end to end in the PostgreSQL database. But more importantly, it gets published out through the agent, right? That agent, it will go to the architect. The architect figures out which agents need to get that information. They all analyze that stuff in parallel, return their insights, and then publish the synthesis coming back from the agent back all the way back to the user. So pretty straightforward flow. Not a lot to that. So a lot of the methodologies I like to use in writing this is test-driven development. I don't know if a lot of people use this methodology, but it entails using red tests. You write your tests first. Then you have green implementations, which are your basic implementations to pass those tests. And once you get all that worked out, then you move into the blue phase where you start refactoring those implementations to be more and more sophisticated and to flush out more and more of your features the whole time running your tests and making sure those tests stay running. It's huge for me because as we're doing this, we all know eventually these agents are going to fail. They're not going to make it to the end usually. And then at some point we have to take over. And I find that starting out at the beginning, thinking about your architecture, your methodologies, and your deployment considerations, it can make the difference between where it leaves off, what state it's in when it leaves off, and how hard is it going to be for you to figure out where it leaves off, and how hard is it going to be for you to get it across that finish line, right? So testing helps you do that a lot. It allows you to check it every step of the way. If the test starts failing, you can just tell him, whoa, back up. What did you do? Start fixing this stuff, keep you a little bit more track. And then when he finally does, when you finally figure out that, maybe I just need to take it from here, then the tests are a good way to start out. Run your tests, find out what's broken, go look at your test. It'll give you a lot of insight on how they actually implemented. The agents implemented it in the background. And it'll get you on track for actually finishing it rather than sitting there frustrated, waiting for somebody to help you try and get it across the finish line. And, truth be told, you might not ever. It could be in such a broken state that it's not something that you're ever going to fix without putting just as much time into it as if you just wrote it from the beginning yourself. So, the big challenges I found with this was observability and governance and tooling and processes. Constantly, Claude, I primarily use Claude Code for actually doing the coding here. And as y'all well know, at some point, he's going to compact his conversation. Mm-hmm. And that compacting is, kind of lines up with his context. It also kind of lines up with his accuracy, right? The longer running his tasks are, the less and less accurate he's getting. The closer and closer you get to compacting that context, you got to start thinking about, okay, he's gonna start losing stuff here. So you got to start preparing for that. One of the things I did was turn off the auto compacting and then just manually tell him to compact. And when you do that, you can actually give him instructions on how you want to compact. If you don't, he just kind of looks at what you've done. He looks at some of your documentation that he may or may not have kept up with, and he'll compact based on that. And then he'll go forward thinking that's the plan. He'll lose half of your information, like he'll stop doing the TDT. If you're having them run agents in parallel, a lot of times he'll just dump out and go right back to a single agent again. He likes to do that. Yeah, and he'll do stupid things like go and take your tests, and you tell him don't do anything till the test pass. So he just goes and mocks all your endpoints. Yeah. Yeah, it's real fun when you get a month down the road on something, or at least a couple days, couple weeks, and you ask it, why isn't this endpoint working? And he's like, oh, because of the mock in there. It's like, I told you to remove that like a week ago, right? But it was still there. So a lot of governance, a lot of governance. And to that point, I'm finding that observability is probably one of the biggest things I need to figure out. I asked it to do observability, and in its infinite wisdom, that meant to it that I wanted observability on the app, not on him. And so he did not observe himself. He did not set up any observability, nor would he. I don't think he would ever want to. So being able to set up that observability on your agents, I think is a big thing. One of the things I'm working on is trying to get that observability and get that into a feedback to the agents, so to keep them on track. Because a lot of things they did, regression analysis, regression prevention, regression guard, right? As he compacts, he starts going off the rails, starts losing his brain, starts losing his his instructions. You can remind him of that stuff, but then he also is taking up his context all over again, and then you're going to compact soon again, right? So to what some of the other presenters talked about, like LLMs as a judge, how do we take those immutable logs out of the agent space, record that information, then maybe have some LLMs as a judge, not just looking at what has happened and is it repeating, a hallucination, but also looking into trying to figure out the thought process. What caused the LLM to go this direction? What caused him to make this decision? Kind of sentiment analysis over the long running chain of output from that LLM. And then being able to have that judge kind of inject coaching back into that LLM to try and remind him of either the architecture, the rules, what his tool sets are. A lot of times, like if you're using Python, virtual environments, just about every 10 minutes, you got to tell him where the virtual environment is, because he'll just forget about it and just start trying to, oh, look, it doesn't work. Well, yeah, none of the libraries are installed there. You got to go activate the virtual environment, right? So yeah, context and rules. Kind of covered that already. Regardless of the instructions, they were going to end up eventually stop using subagents, stop following your rules. He's just gonna go off the rails. And then, as the previous slide mentioned, constantly catching them trying to do things that I'm really not comfortable with. When you look down and it says, I'd like to write this file, and you see dot dot backslash dot dot backslash dot dot backslash dot dot backslash dot dot backslash, and then the file name. Pretty certain he's outside of your project directory writing something into your system files somewhere, and you need to stop that, right? So auto accept of your edits only if you're brave, only if you feel like rebuilding your machine at the end of the day. Design constraints, yes. I've already covered one, TDD, but if you're going to be using multiple agents working kind of by themselves, then something we didn't do with just normal synchronous agents was kind of get into the nuts and bolts of why, right? I'm asking you to do a certain thing. He needs to know why, because eventually he's going to have to make a decision. And if you're not in the loop, he needs to know which way to go. And the better your information on why, the better your rules, the better your feedback loop into it, the better decision he's going to make on a more autonomous, asynchronous type of decision there. Yeah. What to do better? A lot of it. So one of the biggest things that I figured out was that whole YOLO approach, not really considering the architecture, going with the horizontal layered architecture, and just basically asking him in one big giant prop to create this very complicated system did not work out well, as everybody would suspect. A lot of the issues, and this is probably something more to do with Claude, his context. Gemini has bigger context, but other trade-offs. And I'm sure in the future, the context is going to get a bit bigger and it may not be a big issue. But the longer he was running, you've heard this before, the more complicated the task and the longer he's running on that task, the more likely he was going to go off the rails. I had moments where I had 3 different implementations of the same agents in 3 different folders. I had 2 different front ends in 2 different folders, right? He would just start kind of losing his mind. And the reason why it's taken so long is because I've had to go back and tell him to refactor over and over and over and over to eliminate all of that. Not only that, he'll leave trash everywhere. Let me just do a simple script to do this, and he just leaves it there. Let me do a simple script to do this, and he just leaves it there. Next thing you know, you're looking at your code base. You have no idea what's actually part of your code base and what's just trash that he's just leaving around on your code base. So that's another issue. But in my thinking and going forward with other projects now, it makes sense to really limit the ask, right, to the agent. And if we go back to something we've already been doing, those of you that have been part of a Scrum process, then you're probably real familiar with user stories, finding single features, single tasks, single, clean architecture type of tasks and breaking those up into user stories. And part of that process is just laying out not only the individual tasks, but which order they should be done in, what is blocking, what is non-blocking, things like that. And again, deep research is amazing for that, right? Mm-hmm. We used to have to sit there as a Scrum master and just write user stories until our eyes bled and our fingernails were falling off, right? It was terrible. But now we have great tools like Gemini. I'll show you an example here in just a second. Went to Gemini, I said, look, this is what I'm going to do. This is how I want to break it down. Again, a couple of days worth of just discussing what's the architecture look like. I want to use this, tell me about this because I'm not sure, just really doing a lot of planning. And then at the end, telling it, look, I need you to take this whole ask and I need you to break it down into individual user stories. And I want to know what is blocking, what is non-blocking. I want it to lay it out. I want all the context. I want the problem clearly stated. I want the context in there. I want any DB changes, any AI, API changes, all of that information put into each user story. And then at the end, I tell it, you know what? I'm going to have Claude do most of these user stories. So go ahead and create the most effective and efficient prompt you can possibly think of to have Claude complete this little chunk of coding the most efficient and accurate way. And so by doing that, you're really limiting down the ask, right? You're really limiting what he needs to think about, what he needs to do, and what he needs to perform. And the smaller the ask right now, it seems like the better that they're doing. So our traditional Scrum processes work really well for that, right? It's real tempted to just go, I just want you to get it done. Well, we can get it done still a lot faster and a lot more accurate, but we still got to follow some common sense, practices that have worked well for us in the past. Architecture. So after this little journey, I'm not nearly as comfortable running Claude Code or Gemini on my laptop anymore. There's not enough process isolation, not enough disk isolation. Find them doing things I just don't really like. And then you make a mistake, like AIMUG. For whatever reason, I couldn't log into it. So I got lazy one night and I said, you know what? I just need you to change my password to this. Well, it wasn't a password I use anywhere else in my system, but next thing I know, it's logging into EmoJourn as me and writing my own journal entries for me. So just be aware.
Wow.
Yeah, and you can see that actually in the previous thing. So part of the issue with Claude is context size. Part of the issue is, running that over an API. The API is going to have limits. If you don't compact when it tells you to, you're going to get a 429 from Anthropic, basically bad request because you're just sending me too much damn data. So one of the things that I've been working on is bringing that stuff local, right? Getting it off the network, getting it isolated into GPUs, getting Claude isolated into dev containers, if anybody's ever used those. You can fire up VS Code with the dev container plugin. You can set up your scaffoldings to have the .docker.json file in there. And anytime you fire up VS Code, it'll ask you, hey, this is a Docker container. You want me to refire up and connect everything from VS Code directly into the Docker container. And so that's one of the things that we've been working on, trying to do that. As having it in a Docker container, it gives you a great ability to control what comes in and out of that Docker container as well. And if they screw with your disk and your memory, well, they're just screwing themselves up, not you. So, yeah, so real agents. Another good trick is I found is when I go and I do want to use multiple agents, it's really beneficial to actually lay out what each agent should be, what his role should be, have some of them act as judges on your actually coding team, right? Have a regression manager that's sitting there watching. You can use something like a Slack channel as a common interface for communicating, or you can just tell it, you know what, just keep all your logs, every one of you just refer to this MD file and y'all just keep synchronized through that MD file. It doesn't have to be complicated, but they really need to be able to communicate with each other so that the judges can keep the other LLMs on track. And with that, I was actually able to, that was very successful. I was able to vibe code an A/B tester for testing models in my GPUs. And so, yeah, I'll just kind of skip through here. Kind of talked about all of this. Why am I going backwards? Two fingers, not one. There we go. All right. So actually, with that in mind, I took all those lessons learned and created an A/B tester for LLMs and did a bunch of A/B testing, trying to figure out which LLM is going to be best to just have him local, start wrapping him up in dev containers, deploying him into Kubernetes clusters and deployments. And so this is just some of that information there. This actual uses an LLM as a judge. So I just tell it which two models off of Hugging Face I want. It'll load them up. It'll sit there, go through the process of loading them into the GPU. And then it gives them both a standard Python test. And the LLM measures it for speed, accuracy, and completeness. And so that was really beneficial. Again, give your agents real jobs, right? Project manager, front-end developer, back-end developer, DBAs, infrastructure engineers, right? Because not all of us are CI/CD experts, right? It's got to be deployed somehow. Security, another good one, and automation. So with that being said, here is just quick code. The use of LangChain was great because we were able to set up I was able to set up a base agent, right? And then since we got 6 different agents, we were able to basically just create, abstract that out into 6 different agents with their own prompts, all that information. Ideally, right now, this is running as a Celery process. Ideally, I would want every one of my agents to be in Kubernetes, running in its own isolated process, all talking to some kind of asynchronous, either Kafka, MQTT, RabbitMQ, something that can offload that information to and from into those containers. I want observability, everything those things do. I want it to go outside the container. I want it to go somewhere else where there's another LLM looking at it, judging it, figuring out what it's doing, why it's doing it, and then feeding that information back into the container, back to the LLM to keep them on track, to keep them from doing things like creating multiple copies of the same service, trying to screw up his own dev container, things like that. And just finally, kind of to the point of, use your Scrum, like we've always done. This is just an example of a story that I was able to get, a whole slew of them, actually, that I was able to get Gemini to help me develop here just in the course of a couple hours. And yeah, so you can go in here and it just gets very detailed. The more detailed you are with him, her, whoever it is, the more detailed you're going to get in your stories here. But this just kind of breaks it down. This is the basic story, the context, the acceptance criteria, which are all pretty important for your Scrum process, your changes that are proposed. And then lastly, if we're going to do this for an agent, then, let's just keep in mind that this story is not for a person. It's probably for an agent. So go ahead and have it generate your very targeted prompt for doing that story and that story only. And if you look over here, you see blocked by. This is all information. It's blocking these 3 tickets and it's blocked by these 2 tickets. So to the last point I'm going to make is no code should get checked into your repo unless it's had a person review it at this point, right? This will help you with that. If you just had a bunch of agents checking in code and PR requesting, good luck. You're just going to be reviewing PRs for the rest of your life, right? But as long as you got this laid out like this, where you got certain things blocking and certain things unblocking, as that code gets checked in, that kind of creates a pace, right? A pace of development. If y'all have ever heard of sprint velocity, you create a sprint velocity with your agents, and then you're able to kind of tune your sprint velocity for how fast and how many people, real people, you have looking at your PRs and evaluating that stuff. So yeah, that's it.
Awesome. Thank you. We'll open up for
Any questions? Thank you.
few minutes of questions, and then we're going to bring Ryan up here for his lesson learned. So questions.
So you mentioned that you migrated the code from not using a framework to LangChain, LangGraph.
Yes, sir.
How was that experience?
It was actually easier. Initially, he was trying to do it all without using a framework, just pure Python code. And when I went back and I told it to use LangChain, because it is again, another framework that's well documented, you can actually just send it to the website and say, hey, here's the API, right? I want you to convert all of this garbage into something that looks really nice, when explicitly told it use base classes, abstraction, typical software architecture terms, and it just went and did it. It was actually much more successful with LangChain than it was trying to do it by itself. So
It's quite interesting because one of the biggest complaints with LangChain was the documentation, and now how far we've come that agents are able to read the documentation and create functioning applications.
Well, it's good that they do, because it seems like we don't.
yes, sir.
Rabbit best bus
Mhm.
that are, I guess my typical usage of a message bus was to I had to filter through a huge flow of events and integrate with a microservice.
Mhm.
So what was the utility of using a message bus there? Is it because you have multiple agents and subscribers to the message bus?
Exactly. Yeah. So if I did think about it like this, if I send that journal entry into the architect and he's got to process it, and then depending on what his initial judgment is depending on which other the 5 agents he was going to send it to. Then if you're thinking synchronously, that's the processing, waiting. And if you got a user sitting there waiting for that, that's not a very good user experience, right? Chances are a lot of times your HTTP request might just time out while you're waiting on it, things like that. So it's beneficial, especially given the asynchronous way that the agents work. It's just magic to just disconnect that processing from the user somehow. And using one of those as the message bus is a great way of doing that, right? Then you can also abstract out your back end, right? And you can put that behind a load balancer once you start doing things like that. And so then you start getting into being able to scale this out even more and more when you're using asynchronous message buses like that. Yes, sir.
Can you repeat the question too?
Yes. So initially I gave it a architecture to to use Docker containers for everything. And that wasn't working too well. So one of the last three factors, I said, you know what, let's just get this done. I want to see what you're going to end up with. And it kind of chose to use Celery on its own. I kind of let it do that. And it took a minute, but it finally got it running. In fact, it didn't actually finish the Celery configuration until I was just sitting there while you were doing yours. So.
And I love that, by the way. I think you've embraced that notion of it's totally cool to hack on code right into the moment you're on the podium.
Yeah. And a lot of this is just this is only my second meeting here. I'm just gotten into AI at all for the last couple of months. I just been doing a lot of other things, but the learning in the open has really been very helpful for me. So I just wanted to give back to y'all as well. So.
Well, I know that I appreciate it. I think I speak for us all. Appreciate, especially second meetings, being like, yo, this is my code. This is my thought process. And I know I've been inspired and learned a lot from what you've shared along the way, and especially from what you've shared in this presentation. So I want to give you a round of applause. Thank you very much.